is data flow modeling? I told you it depicts how processes transform input to a specified output. So you have a process. They say it's a process. In your terms, you can call that to be a function. A function definitely gets some input. A function gets some input in the form of a trigger or parameters, anything. Something should trigger a function. Only then it will work, right? And a function should give an output. In DFD terms, you can call that function to be a process. A process requires an input and definitely it should give an output. For instance, posting attendance is a process, right? What will be the input? Attendance data will be the input. And after I post the attendance data, should that process give me some feedback? Yes. Data updated successfully. So there should be some feedback from a process. So without that feedback, we'll not be sure about whether that process really worked or not. And every process has some output. Please understand that. So when you're designing something in DFDs, you should get some input to a process and you should also have an output to the process. So what is the data flow model? It's all about processes and how these processes transform an input to a specified output. That's the four fundamental. And what other things you can identify in a data flow diagram? Who is sending you this data? If somebody is giving an input, who is that user? Who is that external user? It can be a person, it can be a system. To identify external entities using your process. And somebody is getting this output, right? Who is getting this output? Whether he is a user or an external entity, or is it some other process which is getting an input from this process and working? So these things we'll be identifying in our data flow models. Another thing that we'll identify is where is the data stored? Is it going to a data store or where exactly, to which table it goes, something like that. At a very high level, we'll depict this. Follows the top-down approach towards decomposing processes. That is, say you consider this to be the main process for your system. You can call this level 0. That is one big process. You'll identify all the inputs and outputs for your system. Then you can decompose this process as level 1. So this is level 0. Level 1 is you'll decompose this one into 2 sub-processes. It's like having a main decomposed into sub-functions. And again, the input will be the same. And this function will be calling this function and then it will be giving the output. So if you feel that this particular process is very heavy and you have to still break it down, you can go and break it down. We'll just break it down. And you see here, we are getting this 1 to be decomposed as 1.1 and 1.2. And what will be the input to 1.1? The data item will be the input. It will process it, give it to another sub-process 1.2. And whatever that is coming out of this will be given to this process to get the final item. So just breaking a process into series of sub-processes. That's it. And one more thing you have to say, the topmost process is given in level 0. And then when I break it down, I go with 1 and 2. When I break 1, how is that I'm going to give it as 1.1 and 1.2, so that I can really map that these 2 sub-processes belong to this process. And these 2 sub-processes belong or being called from this process. Okay. So I'll show you this sample data flow diagram, how our final output will be. So this is our final output. And to understand this, let's take a scenario and start constructing this. Even before going in for construction of a data flow, we have to understand the notations used in a data flow model. So these are standards like you do in a flow chart. You have standard notations in a DFD. What are those standard notations? You represent the process using an oval. A process can be anything. Like I told you, posting attendance is a process. You represent that using this shape, and the input or output that's coming in, you associate that with the process. You call that data flow. So for instance, posting attendance, what is the input that's coming in? Attendance data. So how will you mention that? You give an arrow mark and say attendance data. See, please keep in mind, we are not doing an flowchart thing here. We are doing here a data flow modeling. What is the data entering into your system? What is the function that is processing it? What is the output? There is no if-else modeling here. Okay. So whatever that you should give on the arrow mark should be only data. Attendance data means some data that is going in. Maybe present or absent is the data that is getting in. You should never say if or else here. That is not data, that's a condition. External entity, it can be a user who is using the system. It can be another system that's sending in the data, right? So the external entity is referred using a box. Mostly it's not a rectangle, it's like a square shaped box. So you have to put the name of the entity inside, say it's a user, you give user, and then you connect that to a process. And what the data the user gives, you can give attendance data on top of this. Okay, you write the data that is flowing in. And what will be the output? You have to give the output data too. Okay. The last thing that you're seeing here on the screen is nothing but the data store. Data store here represents maybe a file or a database table that you're going to use to store your data given by the user. Okay. If you're storing your data internally in your system, you use this data store for representing that. So these are the notations, and now we'll take up a scenario. This famous scenario which I have used for requirements gathering too. The loan application submission system. So what this system does, say I have gathered some requirements, I've just given the user requirements here. What are the user requirements? We have already gone through this during our requirements gathering phase. Let's assume that user, the bank customer, wants a loan and he is using your system, loan application submission system. What he does here is he is going to fill in, let's for simplicity assume that he fills in only this data: name, address, monthly income, and loan amount needed. And I'm going to call that as loan data. So user submits the following data for loan application. The second step is there is a verification happening in the system. If name and address is not null and monthly income and loan amount is greater than 0, then loan application gets submitted to the database. So there is an internal validation built into our system which does this. Automatically checks whether name and address is null. And it also checks for these conditions: monthly income and loan amount is greater than 0. And if this data is valid, then it will be submitted to the database. The next thing is loan officer approves the loan application for further processing. The loan officer will enter the data in the database and approve the loan for further processing. Bank managers view a report of all the loan application. So if there is, I'll say bank manager, not managers. So he will view the report of all the applications submitted using the database. So this is the scenario that we have taken. We're going to see how we construct a data flow model for this scenario. Obviously, I have some issues with my data flow model too, but I'll tell you step by step how to go with it. Okay, the first thing is you'll go ahead with level 0 context diagram. This is the first level that you have to construct in a data flow model. What is that is you show the entire system as one big process. The loan application submission system, right? You show that in one single process. You name that, you give 0 to be the process ID. The next thing that you have to identify is who are the users of this process. Who are using this process? Can you identify the users? Who are the users from our discussion right now? Who will be using this process? Loan application submission as a process. Who will be using it? Users are the bank customers. So these guys are nothing but external entities. So I'm using this notation to represent. Who are the other users? You have loan officer and bank manager. So once when you identify this bigger process and then the 3 users, the next thing is you have to check what data goes into the system from these users and what data comes out of the system for these users. So you have to model the data that's flowing in. So from the user, what data will be going into the system? Loan data. When I say loan data, it's about username, address, monthly income, and loan amount needed. So I'm just talking about the data that flows in. This will process it, store it in the data store. And loan officer, is he sending some data to the system? What loan officer does? approves the loan. So when he approves the loan, obviously he gives his own ID timestamp of approval for a particular loan. There will be a status change for the loan. So loan officer, what data he adds to the system? Approval data, like which officer approved, what is the timestamp of approval. Bank manager, what he does with the system, what data he gets from the system? Loan submission report. So there is a report that is getting generated from this particular system, and then I'll not say system is the process. We can think that to be the major process that does everything for us. And you're going to get loan submission report out of the process to the bank manager. So this stage is very important. You have to identify all the incoming and outgoing data for your system. Okay. So after this, we can't really write everything inside a main function, right? We have to think about breaking that into smaller functions. So you have to break this loan application submission into smaller functions. What functions can you think of? Even before going into this, let me ask you one question. How many incoming arrows are there for this process? We have 2 incoming arrows. How many outgoing arrows from this process? 1. So that you have to be very clear with. Next is how to decompose this process. So I have decomposed it like this. So that becomes our level 1 DFD. From level 0, now we'll construct another level that is level 1. That is decomposition of level 0 like this. Validate loan data, update loan database, approve loan application, generate loan report. So there should be some function that will get the loan data entered and that will validate it. If user ID is null, if monthly income is less than 0, you have to display printf some issue. So there is a function or a process that takes care of validating loan. If that process finds the data to be valid, then what will it do? It will update the loan database. So you will call the loan database, write a SQL query, connect to the database and update it. So this function will internally call this function, or this process will invoke this process. So that is thing. And approve loan application. What is this particular process used for? Say this user loan officer wants to approve the loan, right? He needs a process for that. The loan officer will interact with the system. There will be a function running which will get the particular loan info, and then he will say approved. So it will in turn add the data of approval to the database. What is generate loan report? This will be used by the bank manager. So whenever he wants a report, he will interact with this function which will run a query and generate the report for the manager. So you decompose that like this. And now what all we have to see in the next step is we have to still maintain the input and output from the system. What is the input to the system? It comes from the user, and that's the loan data. This loan data will be fed to our function. If the data is valid, so valid data where it will be passed to. So this is again data. It's not an if-else condition. So valid loan data will be passed to update loan database module or function. You call that a process here. It is actually a piece of code that will actually execute and update your database. So when I am saying update database, I am storing that in some data store. So you should mention the data store where this process stores that particular data. So here this valid loan data is actually going to the loan database. And this is how you represent a data store. You should always keep in mind you give a data store only in from level 1. You should never include a data store in level 0. That is the previous diagram. You should always include a data store only from level 1 decompositions. Approve loan application, who is going to use that? Loan officer. And what will be the input? Approval data. Timestamp, officer ID will be added to the loan database against that loan. And this will also be moved to the loan database, you see. Generate report. So whenever say our bank manager interacts with the loan database, from where this report will be generated? What is the source of information? The loan database, right? So you see here, generate report will be the bank manager's use case. So you're going to get the report generated from the loan database. What is the data flowing out? Loan submission report. So again, you have to ask this question: how many incoming arrow marks to our system? So where is our system? This is our system. Say we have broken down level 0 process as certain other processes like this. But what is the system in final system? This is the system. How many incoming arrow marks to a system? 1 and 2. How many outgoing edges from the system? 1. Is it in sync with the earlier level 0? When you take a look at level 0, is that in sync? We have 2 and 1. See, this is very important in data flow modeling. The number of incoming and outgoing edges or data flows from a system should be consistent across all decompositions. This is called balancing a DFD. Balancing a DFD. See, all of a sudden in this level, you cannot have some 2 more users and 2 more data flows into your system. That creates inconsistency, right? Because this is something a decomposition of the level 0 flow. So like that, you can keep on decomposing any process you think can be decomposed. From this, can you identify any process that can be decomposed? Or can I leave it to this granularity? Granularity in the sense, can I start giving that to a program to give some idea about what's going to happen in the implementation? So can I leave it to this level or can I decompose it further? I will show you one small example. Say I'll take process bubble 2, I'll decompose it as 2.1 and 2.2. What is the input to this particular process bubble? There is one incoming edge. And what is the output? To the loan database, we have an outgoing edge. So maybe we can try and think of decomposing this process bubble. How will I decompose that? Let me show you. Establishing the connection to the database itself can be a separate function, which I can reuse across many of my other modules. Maybe we have a connection string and we have the URL to where we have to connect. So obviously they will have a connection function. So connection to a database itself can be a separate function that can be reused, wherein you will have the user credentials and the connection string. Once when the connection is established, a valid connection will be returned. And you'll have this update database, which is another function. Once when the connection is established, this function will use the connections for updating the database by running a SQL query on it. So this is this particular function that will actually run the SQL query. So I can even modularize my connecting to a database. I can even modularize closing the connection from a database. So why should I modularize that? Break it up like that is, if I'm going to write another module, I want to connect and close, just call this function. And what is the input to my level 2? Valid loan data. And what's the output? Loan database. So we have identified the levels in our hierarchy. Maybe I will just show what kind of tall hierarchy we have here. We call that tall hierarchy in technical terms. I'll just show you how we have identified this tall hierarchy. It should be like a main process. From there, we are invoking all the other sub-processes, right? What are the sub-processes? Say, for instance, if this is update database, we have two things: connect to database, and then from there, we are going to call update data. So it's a series of calls happening here. And what is flowing between these calls? Data is flowing. Is there an if-else condition flowing between your functions? No. So that is what is a DFD. I will say DFD is considered to be not so frequently used technique. We will not go in for such techniques until we have a very complex function that should be described in a very neat manner to all our developers. But then it's very useful when you have a very complex system with a lot of function calls, so that your developers will be having some idea about how things work. So that's how you construct a data flow diagram. The only thing is you have to balance the DFD, you have to maintain the number of incoming, outgoing edges consistent across your decompositions. We should decompose it such that wherever possible we can reuse things. Okay. There are some rules for a DFD while you're constructing it. Say a process should definitely have some input and output. You cannot have a process without an input but just generating an output. It's like I without even opening Vita, it starts giving me a lot of output on its own. It becomes too intelligent. Not even switching on, it just directly starts printing everything. Right? That's the meaning if you have something like this. So you should not put, this is wrong. If I want to post attendance, I will just click on post to trigger that process. And then after posting attendance, the output that will be coming back is attendance posted message will be coming back. Again, this is actually I'm missing here something. This is actually wrong. We should have an output. A process should also give you an output. A process without an output is useless for the users. It's useless for the system. Say some function gets some input and it's dormant. It not do anything. It should give some feedback, some message. It should do something. Some output should be there. Another rules, these are some of the common mistakes I've seen with DFDs. Say, if you are having two data stores, one database here, one database here, you need a process in between. Say, I am importing data from one of the databases to another database. There will be a function with reading the data, writing the data, right? Directly, two databases cannot talk to each other. MySQL cannot talk to Oracle, and directly they cannot do an import or export. So that's why a process is needed in between two data stores. You should never model something like this because it has no meaning. This can be MySQL database. This can be your, say, graph database, something like that. How can data from two databases exchange without a process in between? Please ensure that. And again, another common mistake I see with DFDs, only a process can help a user interact with the database, right? When you are working with VTOP, are you directly working on the Oracle database that VTOP supports, University Management System? The user will not be given direct access to any database management system. So that is the meaning. If you just directly connect it like this, user and loan database, it means that you don't have software at all in it. So that should not be there, and user cannot retrieve data directly from your database. Of course, database administrators, they are a different category. You will not bring them here. This is like common users. You cannot go and directly retrieve a report from your Oracle database from a University Management System by typing a SQL query. Another very funny thing to actually explain, but let me explain this. Say this is an external entity, this is an external entity. Maybe a user here and another user here. Sometimes students model this, say loan officer and bank manager in the DFD. The loan officer interacting with the bank manager outside the system is of no importance to us. Only when they interact by using a process, it really matters to us, right? So two entities interacting away from the system, why should we even put that? They say they may be talking to each other. That doesn't matter. We are focused on developing a system here. So these are some of the DFD rules.